All right, so 11d, I probably should have just done this all together, but I guess that video was getting too long for me. Um, so if we use both the integrals that we found, right? So I'm going to use, if I use the first integral, it would just be sine squared of x over 2. Since we have a definite integral, we know that we don't have to worry about that constant. So we are evaluating this from 0 to pi over 2. And in the second example, we're using negative cosine squared of x over 2. Again, it's a definite integral, so that constant's going to cancel out. So 0 to pi over 2. So let's see what we get. So if we go with this first one, we're going to get sine of pi over 2 whole thing squared. That's what it means, sine squared, minus sine squared of 0, or sine of 0 squared, rather. This whole thing over 2. All right, so the sine of pi over 2 is 1. So this is going to be 1 squared, which is 1. Sine of 0 is 0. And over 2, so we get 1/2. So this antiderivative gives us 1/2. If we were to throw it in here, I'm going to pull the negative out. So we're going to get a cosine of pi over 2 whole thing squared minus cosine of 0 whole thing squared over 2. Cosine of pi over 2, that's 0 minus 1 squared over 2. So we're going to get, be careful with signs. We're going to get negative 1/2 in here, right? We square the 1 first and then negative times that negative. So positive 1/2. Right, so either way we get the same answer. And the reason, kind of similar to the logic from question 11c, if you watched that latter part of that video, right? So this constant gets absorbed. Well, when we drop off the constant in our definite integrals, we don't need it anymore, right? So it doesn't affect things at all, right? So we should end up getting the same exact value, regardless of how we take this antiderivative.